स्टार्ट.
माझं नाव सांगी आहे. माझं नाव जान्हवी आहे. हे सिव्हिल इंजिनिअरला सबस्क्राईब करा. मला इंजिनिअर बनायचे आहे.
ओके, गुड.
नमस्कार मित्रांनो, संतोष बोलतोय. हाय एव्हरीबडी, संतोष हियर and today I am delivering my regular lecture on intake structures and water demand, that is lecture number 2 on water supply engineering. This is very essential and important lecture as far as water supply engineering is concerned, and this lecture might be useful for you for your preparation of competitive type of examinations such as Mpsc, UPSC, and it is also useful for degree as well as diploma level students for preparing this subject. So let us start this subject, but before starting I am requesting you to subscribe my channel and to get the ideas clear about civil engineering, and it is also a request to listen the lecture till the end to get more and more ideas regarding the subject. So let us start my lecture number 2 regarding water supply engineering, and I am going to describe some part in Marathi also considering preparation of Mpsc examinations. So let us start the lecture. The lecture deals with intake structures as well as water demand. First, we are going to discuss the intake structures and site selection. Do you know intake? Intake name itself indicates it is the intake of water from river, reservoir or a canal for water supply. The intakes are the structure used for admitting the water from the surface sources as described earlier, river, reservoir or a lake, and conveying it further to the treatment plant. So the water is collected from the intake and it is taken for treatment to treatment plant. An intake is a masonry or concrete structure with an aim of providing relatively clean water free from pollution and sand as well as objectionable floating material. That is very important. So we get the water reasonably clean to treat it for drinking and other purposes. So let us discuss about selection of site for intake. The site should be so selected that it may admit water even under worst condition of flow in the river, under lowest possible water level in the lake or a reservoir. म्हणजे काय आहे की नदीतील पाण्याची पातळी कमीत कमी जरी असेल तरी हे पाणी आपल्याला ट्रीटमेंट प्लांटकडे नेता आले पाहिजे अशी आयडियल साईट इंटेक स्ट्रक्चरसाठी हवी असते. इट्स साईट शुड बी as near to the treatment work as possible. It should not interfere with the river traffic if any. If there is a navigation, it should not interrupt the navigation. The intake should be so located that good foundation conditions are available and possibility of scoring is the least. We discussed the scoring in bridge engineering. So that scoring should be minimum. Scoring means cutting of the bed of the river, and good foundation is required for every structure. It should be so located that it is free from pollution. River intake should be constructed well upstream point of the discharge of sewage and industrial waste. What it means? It means that in Marathi, जेव्हा सिवेज किंवा घाण पाणी हे खालच्या बाजूला असेल तर ते डाउनस्ट्रीम साईडला जर आपण इंटेक जर लोकेट केली तर हे घाण पाणी त्या इंटेकमध्ये येईल आणि या घाण पाण्याला जास्त ट्रीटमेंट द्यावी लागेल. हे टाळण्यासाठी आपण इंटेक स्ट्रक्चर हे सिवेज लाईनच्या अपस्ट्रीम साईडला, म्हणजे जिथं पाणी शक्यतो शुद्ध आणि चांगलं असतं अशा ठिकाणी आपण इंटेक स्ट्रक्चर लोकेट करतो. द साईट शुड बी सो सिलेक्टेड दॅट इट्स फर्दर एक्सपान्शन इज पॉसिबल. सध्याच्या काळाची ही गरज आहे, कारण अशी साईट निवडा की भविष्यात त्याचं तुम्हाला एक्सपान्शन करता आलं पाहिजे. Then we are going to discuss types of intake structures. What are the different types? The types are river intake. Name itself indicates it is located on river side. Then second is the reservoir intake, third is the lake intake, and fourth is the canal intake. So river, second is the reservoir, third is the lake, and fourth is the canal. River intake. The river intake is located on the upstream side of the city so that pollution is minimized. They are either located sufficiently inside the river so that demand of the water are met within all seasons of the year. Means perennial supply may be available at that site. They may be located near the river bank where a sufficient depth of water is available. So depth of water is also a consideration. So let us see this figure. This is the figure of river intake. This is the river bed. This one is the river bed. This is the river. This is the lowest water level in the river, and the water is collected through these penstocks and screening is done here. From screening, the suction pipe is provided on the pump and water is lifted and the water is transported towards the treatment plant. So please remember this figure, because now from year 2023 all the Mpsc papers are the descriptive, so you must know all the figures and function of that river intake. This figure shows the wet type of intake well founded on the river bed. Okay. Now the second type of intake is the reservoir intake. When the flow in the river is not guaranteed throughout the year, a dam is constructed across the river to store the water into the reservoir so formed. So the reservoir intake is practically similar to the river intake, except that these are located near the upstream face of the dam where maximum depth of the water is available. This figure shows the typical intake for an earthen type of dam with several entry points. The intake is constructed near the toe of the dam. Okay. Please look at this figure. This is the river and this is the earthen dam constructed to storing of the water, and so that we get the maximum water level. And this is the arrangement. This is the gatehouse. This is the footbridge over that, and these ports are called as a inlet ports, and the water is transferred through this pipe to the treatment plant. So this is a typical figure, and you must remember these figures and you must practicize these figures for descriptive type of examinations. Okay. Then we are going to discuss the lake intake. Lake intakes are similar to the reservoir intakes if the depth of the water near the banks is reasonable. If, however, the depth of the water near the bank is shallow and greater depth is available only at its center, a submerged type of intakes are used or provided, and submerged intakes are constructed as a crypts or bellmouth entry. So please look at this figure. CI gratings are provided to avoid the entry of the floating debris. Then planking is also done with the wooden material. Rock fill type of construction is here, and this entry is the bellmouth type of entry for the for collecting the water and send it to the treatment plant. So please remember this figure. Okay. Then we are going to discuss the last type of intake, that is the canal intake. Sometimes the source of water supply to a small town may be an irrigation canal or channel passing near the town. It is essentially consisting of concrete or a masonry intake chamber of rectangular shape and admitting the water through a coarse screen. A fine screen is provided over the bellmouth entry of the outlet pipe. The bellmouth entry is located below the expected low water level in the canal. So it it should be below the LWL. This is the full supply level of canal. This is the low water level of the canal. This is the coarse screen which is provided. This is the fine screen provided, and the level of that bell mouth entry type of suction pipe or outlet pipe is provided below LWL, and water is transported towards the treatment plant. It is so simple. So you people must get acquainted with this type of figures and the mechanism of that river or canal or a reservoir intakes. Then this is the most important topic or a most important point of the water supply engineering, that is water demand, and all water supply engineering is based upon the water demand. An average person may consumes no more than 5 to 8 liters of water per day in liquid and from solid foods, including 3 to 6 liters in the form of water, milk and other beverages. However, the per capita consumption of the water drawn from public supply is quite large. म्हणजेच घरगुती वापरासाठी जे पाणी लागतं ते कमीत कमी 5 ते 8 लिटर पर डे इतकं लागतं. परंतु हेच जर पाणी आपण सार्वजनिक वापरासाठी वापरत असू तर हे डिमांड मात्र फार जास्त असतं. The total requirement of the water may be divided into the following 5 categories. So you must remember these 5 categories of the demand. First is the residential or domestic use, second is the institutional use, third is the public or civic use, fourth is the industrial use, and fifth is not a use but it is losses, but it is considered in water requirement, that is water system losses, and which plays the vital role in any water supply engineering. So you must know how much type of losses are there in water supply engineering. First of all, we are going to discuss the residential or domestic use. The residential or domestic use includes the water requirement for drinking, cooking, bathing, washing of the clothes, utensils and house, and flushing of the WCs. As per IS 117-1957 recommends a per capita water consumptions of 135 liters per day. So you must remember this figure. For domestic use, the water required is 135 liters per capita per day. Per capita means per person per day. For bathing, amount of water in liters per head per day is 55. For washing of the clothes, it is 20 liters per capita per day. For flushing of the WCs, it is 30 liters per capita per day. Washing of the house, the 10 liters per capita per day. Washing of utensils, 10 liters per head per day. Cooking, 5 liters per head per day. And for drinking, 5 liters per head per day. So total requirement of water for domestic purpose is 135 liters per capita per day. So you must remember all these figures, because all these figures are appeared in competitive type of examinations for objective type. The second type of water requirement is the institutional use. The manual on water supply and treatment recommends the values of water requirements for institutional needs is given in the following table. So you must remember this table. I am going to read this table or going to explain this table for you, which is required for competitive type of examinations. For hospitals, including laundry, number of beds not exceeding than 150, the requirement is 450 per bed, and that is liters per head per day. And number of beds not exceeding than 100, then the requirement is 340 liters per capita per day. So number of beds exceeding and number of beds not exceeding than 100, that water requirement is calculated. For hotels, it is 180 liters per capita per day per bed. For hostels, it is 135. For nurse home and medical quarters, it is 135. For boarding schools and colleges, that is 135. Then for restaurants, the 70 liters per capita per day per seat. Airports and seaports, that is 70 liters. For junction stations and intermediate stations, both railways and bus stations, it is 70. For terminal stations, it is 45. For intermediate stations, excluding mail and express stops, that is 45. For day schools and colleges, it is 45. For offices, it is 45. For factories, it is 45. And for cinema, concert halls and theatres, it is 15. Okay, so please remember these all figures. Then for public or civic use, water requirement for public or civic use may be divided into following purposes. First is the road washing. For road washing in municipality area, a provision of 5 liters per head per day is made. For sanitation, it is 3 to 5 liters per head per day may be made. For public parks, it is 2 to 3 liters per square meter per day, that is in square meter, 2 to 3 liters per square meter per day. For firefighting, it is very important, and question is all the time appearing in the competitive type of examinations to determine the water requirement for firefighting, and Kuchling formula is very important for that. That requirement is Q. Q is the requirement of water in liters per minute, that Q is equal to 3182 into bracket P raised to 1 by 2, where P is equal to population in thousands. That is very important, population in thousand. And some analytical problems may be appeared in the examinations. We will discuss it in our later lectures. Then Buston's formula is Q is equal to 5663 P raised to 1 by 2, that water requirement is more in Buston's formula. In Freeman's formula, Q is equal to 1136 into bracket P divided by 5 bracket complete plus 10. And for National Board of Fire Underwriters formula, that quantity of water in liters per minute is calculated by formula 4637 into bracket P raised to 1 by 2, where P is equal to population in thousands, and in another bracket 1 minus 0.01 into bracket P raised to 1 by 2 and bracket complete. Okay. Then we are going to discuss the industrial use. The presence of industries in or nearby the city has a greater impact on the water demand of that particular city, and the quantity of water required depend upon the type of industry. Then for automobile industry, the unit of production is vehicle. We are producing the vehicle through automobile industries, and water requirement in kiloliters per unit is the 40. Then for distillery, the unit of production is kiloliters, and the water requirement in kiloliters per unit is 122 to 170. Then for fertilizers, the unit of production is ton, and the water requirement in kiloliter per unit is 80 to 200. For leather, ton, and the water requirement is 4. For paper, the unit of production is ton, and water requirement is more, that is 200 to 400 kiloliters per unit. For special quality paper, the water requirement is higher. You know that there is one paper industry near big one, and that water requirement is more, so it is located near the Ujni Dam, and the water requirement is 400 to 1000 kiloliters per unit. Then for straw board, the unit of production is ton, and requirement is 70 to 100 kiloliters per unit. And for petroleum refinery, the unit is ton. For crude, and that is 1.5 to 2 kiloliters per unit. For steel, the water requirement for ton is 200 to 250 kiloliters per unit. And for sugar industry, where the cane is crushed, जिथं ऊस हा क्रशिंग केला जातो, अशा ठिकाणी वॉटर रिक्वायरमेंट 1 to 2 किलोलीटर पर युनिट इतकी असते, 1 to 2 किलोलीटर पर युनिट. And for textile industries, for 100 kg, the water requirement is 8 to 14 kiloliters per unit. Then last water requirement is the water system losses. The losses in a water distribution system consisting of leakage and overflow from the service reservoirs. म्हणजेच आपण ज्या रिझर्वायरमध्ये पाणी स्टोअर करतो अशा रिझर्वायरमध्ये लिकेज असते किंवा अशा रिझर्वायरमध्ये ओव्हरफ्लो होऊ शकतो, आणि हे लॉसेस आपण कन्सिडर करतो. सेकंड इज द लिकेज फ्रॉम मेन अँड सर्व्हिस पाईप कनेक्शन्स, द लिकेजेस फ्रॉम द पाईप्स. Then third is the leakages and losses on consumers' premises when they get अनमिटर्ड हाऊसहोल्ड सप्लाईज, जेव्हा पाणी हे मीटरिंग सिस्टीमवर नसतं तेव्हा पब्लिक किंवा लोक हे पाणी फार मोठ्या प्रमाणावर वापरतात किंवा पाण्याचं नुकसान करतात, त्या लॉसेसला आपण कन्सिडर करावं लागतं. देन अंडर रजिस्ट्रेशन ऑफ द सप्लाय मीटर्स, and last one is the large leakages or wastages from the public traps. Losses in the supply lines are mainly due to defective pipe joints, cracked pipes and loose valves and fittings. In case of well maintained and fully metered water distribution system, the losses may hardly exceed 20% of the total consumptions. So losses plays the vital role in any water supply engineering, and in the system where the supply is partially metered and partially unmetered, in such a case the losses may be up to 50% of the total supply. So a good civil engineer or good water supply engineer may prevent the losses in water supply system. That is very important. So thank you for listening my lecture very calmly, and I am going to request you to subscribe my channel if you find it suitable for your civil engineering curriculum. So thanking you, and for more details and notes you may please contact my administrator. His number is given in this lecture, and my email ID is svkulkarni72@gmail.com. You may inquire your queries on that email, and I am going to give you the solution if possible. So thanking you, bye bye, and meeting you shortly. Thank you very much. Thank you.